I'm Wenyu from the Institute for Infocom Research. I'll introduce our work on rethinking the role of pre-trained networks in source-free domain adaptation. Neural networks have achieved great performance in many tasks. This performance is often relying on the assumption that the training and the testing data, our source and target domain data, are sampled from the same distribution. However, this assumption can be violated when models are deployed in the wild, as the test data may be subject to domain shift. We need to adapt the models in a reliable manner. In this paper, we work with the source-free adaptation pipeline. Firstly, a source model is obtained by fine-tuning a pre-trained network, such as an ImageNet model, on the source domain. After that, the source data is no longer accessible, and the source model is further adapted on an unlabeled target domain. This setting helps to protect source domain privacy and save on data storage. Conventionally, the pre-trained model is discarded. We observe that the pre-trained model can hold more target information than the source model. This is because source training can cause pre-trained model to forget target information. Moreover, modern networks pre-trained on large data may have more robust representations. Target-incompatible source models produce biased predictions on target samples, and relying solely on such source models for adaptation is unreliable. Instead of discarding the pre-trained model after source training, we propose to integrate it into the adaptation process to help correct source model prediction bias. We propose a two-branch framework consisting an adaptation model branch and a pre-trained model branch. The two models co-learn to generate more reliable target pseudolabels. The adaptation model branch is initialized by the source model. The pre-trained model branch is initialized by a pre-trained feature extractor and a weighted nearest centroid classifier. The weights in the nearest centroid classifier are taken from the predictions of the adaptation model branch. We alternate updates on the two branches as each adapts to the target domain and produces more accurate predictions to improve the other branch. We design a simple match or conf scheme to combine predictions from the two branches for target pseudolabeling. For each target sample, the more confident branch assigns the pseudolabel. No pseudolabel is assigned if the two branches are similarly confident but predict differently. We evaluate a method on benchmark datasets covering device shift, style shift, and synthetic to real shift. We use ResNet for source models and a variety of ResNet, SWIN, and ConvNext networks pre-trained on ImageNet for co-learning. Our proposed co-learning improves target domain performance over the source model and existing source-free domain adaptation methods when applied together. Even when reusing the same pre-trained network from source model initialization, co-learning improves performance. Performance gains are larger when co-learning with more robust pre-trained networks such as SWIN transformers. Our proposed method can be applied to other settings as well, such as open set, partial set, and open partial adaptation, and multi-source adaptation. In summary, in this work, we observed that source training can cause pre-trained networks to forget target information. We propose a simple co-learning strategy to distill useful target information from pre-trained networks to improve target pseudolabel quality. The method is compatible with existing adaptation methods and obtains competitive performance for classification. The framework is flexible and allows us to leverage modern networks with improved representation capacity and robustness. Thank you.